This is the last talk of the day, so we'll get into the subject matter quickly and try not to keep you from the happy hour at the end. So, how many people in the audience are familiar with Internet of Things and the Internet of Things use cases with blockchain? Maybe just a quick show of hands. How many people have looked at IoT use cases around blockchain? So 1, 2, 3, 4, 5. Probably about 10 to 20% of the people, the other people perhaps not. So this is fairly basic educational then for most people in the audience. So a few of the use cases that we think we can support with blockchain and IoT. The first would be smart cities. Every single city is going to have IoT devices from dozens, maybe hundreds of vendors, air quality sensors, parking meter, payments machines. There will be many IoT devices in the cities, and so registering the identity of devices, provisioning the history of the device. Is it a safe device? Is it a trusted device? So the transfer of custody from whoever manufactured it. The events associated with the device, so maybe the air quality readings from the air quality sensor. The public will want to know that this data is trustworthy. Payments associated with IoT devices. These are some of the examples of how we can use a blockchain backend to support the registration of IoT devices, basically using a blockchain as a catalog or as a whitelist so that we, as city employees can know which devices to trust, the provenance of the devices, where did they come from, as citizens, the event history or the data from the devices, and overall to coordinate if we have devices from 30, 40 different vendors, kind of the complexity of all of this. So you've probably, based on looking at the agenda, heard a little bit about some of the smart supply chain use cases, but again, the identity of the containers, the events when a container arrives at a particular port or a particular warehouse, we can have a proof of proximity event where an IoT chip on a container signs the chip on say, the gantry crane, and we register this event to the blockchain. So now we have the attestation of the event of the delivery of a container to a port, and now we can tie automated payments. So there could be an insurance payment if a container is late, or there could be a performance incentive payment if a delivery is happening early. There might be release of trade finance. So these are a few examples of how once we have, with one common platform, the device identities, the ability of a device to sign events, and then to trust both the identity of a device, the data or the events associated with a device, that we can use this as an input into a smart contract to confirm milestones to in this case, automate payments. Also, transfer of custody is very important in the shipping case. The fact that we can transfer the identity of a shipping container or the identity of a car in the same way that we transfer a Bitcoin on a totally decentralized basis without any central administrator involved in the process is a very exciting prospect for human progress. Another example would be the drone economy. Drones can have identities, charging stations can have identities, charging stations can authenticate a drone can make a payment to a charging station, all on a decentralized basis. This is another example of how we can use a blockchain backend to register the identities of the drones, as a backend for authentication, and as a backend for payments between machines. So if this future that I'm describing sounds futuristic, it's already here. Between kind of the set of companies and the Trusted IoT Alliance, we've done all of the things described in the past three examples. So I'll talk now a little bit about how we're trying to make this happen at scale globally through a consortia of companies. So some of the financial use cases with blockchain became well known in 2016. 2016 was really the march of financial services firms into blockchain. So you would see consortia of financial services firms coming together And it was really about working together at the smart contract layer to create common protocols to interface business processes, maybe around syndicated lending or some other financial services process through the smart contract, so that an industry club could have a set of common business practices on a trusted, immutable blockchain back end. What we're doing with the Trusted IoT Alliance is creating a similar set of protocols through the smart contract for the interface of IoT devices, products, assets, machines with the blockchain backend. So it could be drones, it could be shipping containers in the supply chain, it could be envelopes and packages for the postal service, it could be smart contract-driven trade finance applications, automated insurance payouts, automotive use cases, industrial IoT use cases. There are many classes of industrial kind of processes that we can support with this back end or solution. So there's been a lot of innovation to date at the blockchain layer. The smart contract layer, we first started to experiment with smart contracts with the release of Ethereum in August of 2016. At Chronicled, the company that I lead with 3 other co-founders, we were one of the first companies to release kind of live IoT interface on the Ethereum platform, and now we're working on 3 other blockchain systems: Hyperledger and Ethereum Enterprise, the Quorum blockchain. So the big idea here is if we can create trusted IoT or device identities. In some cases, we actually hash the firmware and register the firmware as part of the IoT device history so that we know if the firmware is trusted. And then trusted sensor data, we can sign the sensor data with the private key on the IoT chip. If we have all of these things as trusted, now we can automate business processes through the smart contract. So the goal of the Trusted IoT Alliance is industry acceleration, lowering adoption barriers, making it easier for IoT developers to integrate end-to-end solutions, and overall awareness in the tech community. Really about blockchain interoperability. The group is blockchain agnostic, and device interoperability, ultimately supporting maybe all of the classes of IoT devices that you might see on the Azure homepage, for example. I see some of the developers in the audience nodding their heads. So the model that we're working with is about physically secured on the device side and blockchain secured on the back end. So we have a secure on both ends, if you will. So on the device side, if you look at your credit card in your wallet, there's a little chip in your credit card. It's an NFC chip. And the NFC chip has a secure element inside which protects the private key. And we're basically using the same model, putting an identity chip in a shipping container or a drone or any physical piece of property, any object, to create a secure identity in the physical item. And then we're registering the public key of the chip to the blockchain with metadata. And once we create under a registrant identity, we give birth to the identity of this physical item on the blockchain. We create a digital twin, if you will, and this digital twin is a secure one-to-one link with the physical item, and we can transfer the digital twin, so we can do transfer of ownership, say, of a car that would have an identity created in this way. So these are some of the use cases that we've explored. We actually had our first conference as part of the Trusted IoT Alliance back in December of 2016, and we had startups that presented each of these different use cases: luxury goods authentication, your Louis Vuitton handbag; trade finance, sharing economy use cases. So sharing economy would be, renting the public bicycle. Industrial IoT, so this might be like an IoT sensor on the oil and gas wellhead to track the flow data. Autonomous vehicles, local energy trading, And so as CEOs and CTOs of tech companies all working on IoT blockchain use cases, we identified a set of what we call protocol primitives, or kind of command line functions that we need to interface IoT and blockchain. So registration, verification of identity, transfer of ownership, ledgering, which is using the identity, say, of the drone, the private key in the chip to sign the data, sign, the flight, maybe the arrival of the drone at the particular charging station location. And then wallet, which is to allow a device or machine to send and receive value on the blockchain. So these are kind of protocol primitives that the group is working towards supporting, where half a dozen of our startups are all in agreement that it's better to have one common approach to doing these primitives and then competing on application services layer, as opposed to all trying to basically create duplicative approaches to these underlying functions or primitives. You can almost think of these primitives as like equivalents of HTTP in the smart contract. TCP IP was the basic machine-to-machine protocol for communication. HTTP was a standard on top of that. We're using the smart contract to create some of these primitives that can be used by many companies in a common way that can ultimately lead to a healthy, vibrant, growing ecosystem. So you look at the stack. You have the blockchain layer, the public data utility. We all share the blockchain layer. The smart contract layer, which sometimes we refer to as the IoT protocol layer, to register, verify, ledger, transfer, send, receive value. And we're working through the consortia to create an industry standard and open source. So we collaborate at the smart contract layer to create momentum and inertia. And then application services layer, the companies in the consortia will compete. Just like all of the companies were able to compete on top of HTTP. Here's another visualization of the same thing. Blockchain layer, typically Hyperledger, Enterprise Ethereum, public blockchains, smart contract layer. Sometimes we refer to this as FAT protocols, using the words of the UAV venture capital team. I think that's a very apt kind of term to describe the function of the smart contract, the fact that we can create protocols that many companies will use and adopt. The HTTP protocol was a very thin protocol. Even the blockchain protocol, it was very simplistic in its function. The smart contract effectively allows us to program protocols that many companies can choose to embrace. And that's what's maybe different about the blockchain architecture and the smart contract, the fact that we have programmable protocols. And I think that's maybe one of the reasons you're seeing so many consortia in blockchain. It's a natural evolution of the fact that companies and industry groups can create protocols, common business logic, if you will, run across blockchain nodes, immutably verified. Another diagram of the systems architecture that we're working towards. Really simple IoT devices with identities through APIs to a blockchain backend. One of the views of the group is that being blockchain agnostic, at least for the foreseeable future, is almost a prerequisite to success. There's so much vibrancy at the blockchain layer today. It's not yet clear which of the blockchains will ultimately win and become kind of dominant. Is it going to be Ethereum? Is it going to be Hyperledger? Is it going to be one of the branches of the Ethereum enterprise? There are already 4 Ethereum enterprise forks. You have Tendermint, you have Block Apps, you have Quorum, and you have, what is the 4th one? ETHCore, and there probably will be more. So the approach of the group is to create a reference implementation that we can mirror across blockchain systems with the eventual goal to have interoperability for IoT across many different blockchains. So what we're working on at the protocol layer, kind of in common between the different companies, is a collection of generic smart contracts to link IoT devices to blockchain with a common interface. And this can host the IoT device identity, the firmware fingerprint, event logs, the wallet of the device, open source under Apache 2.0. This is like, HTTP for IoT interface with blockchain. And then at the business process level, there will be other smart contracts that are created and proprietary systems to interface, trade finance or M2M payments or pharmaceutical track and trace or other supply chain applications, decentralized energy trading, city device green list. These are all kind of business process specific applications that will need to be built out, and we foresee some of this potentially being open source, but probably the bulk of it will be closed source on top of the IoT protocol layer. So the Trusted IoT Alliance has a GitHub. There's kind of an initial open source framework to register IoT identities, and you can check that out at trusted-iot-alliance.github.io. There'll be a website that goes up in about 2 to 3 weeks, kind of presenting the overall vision, goals, GitHub, and a proposal intake system for the Trusted IoT Alliance. So one of the objectives of the group is that small companies or large companies that are working with IoT can submit proposals for funding to develop use cases using this new set of open source smart contracts. If any of the participants in the audience are interested in the approach, would love to follow up with you. There's a growing community globally across a dozen cities working on kind of these use cases and implementations. So with that, I'll end the presentation and open to questions. Yeah, NFC, BLE, GSM, it's becoming more common in the market that the IoT chips have a secure element or secure enclave. It's 5 years ago, you wouldn't have found cryptographic IoT chips. Today, it's becoming an increasingly large proportion of the market. We may be up against the happy hour here, Mike. Okay, thank you.